Alright, ladies and gentlemen, this is 6-1 Notes, multiplying variables with exponents. Your objective, you'll be able to simplify exponents using multiplication, and simplify scientific numbers using multiplication. So, in our notes, our directions are this. Simplify your answer. So your goal is just to simplify. Your answer should contain only positive exponents. That's what I have here underlined here in blue. So what do I mean by that? Well, in this problem we have here, we have b to the third times x to the negative 2 divided by 1. We cannot have negative power in our exponents. They have to be all positive exponents. So in order to get rid of a negative power, all you gotta do is move it from the top in the numerator down into the denominator. So this x to the negative 2, it gets moved down to the denominator, and you notice the negative 2 goes away. It turns into a positive 2. That's how you change a negative power to a positive power. You just change it from the numerator into the denominator. Now b to the third, it's a positive 3, so we could leave b to the third on top. And this positive 1, well, the positive 1 could stay on the bottom. And that will be your answer right here. And they're in a circle. B to the third divided by 1x squared. Or simply b to the third divided by x squared. Let's practice a few more problems with this concept. So in this problem up here, we have b to the third times x to the negative 3 divided by c. Our goal, we have to get rid of that negative power. So to get rid of that negative power, it's currently in the numerator, so we move it down to the denominator. So we have x to the negative third in our denominator. C, well, c has a positive power, it's an imaginary 1, so we're going to keep c in the denominator. Now b to the third, well, that's a positive 3, so we keep b to the positive 3 up top. And that will be your final answer. What I have there encircled. B to the third divided by c times x to the third. Let's do this next problem here down below. We have a to the third times x to the negative 5 divided by 1. We have to get rid of that negative 5 in the power. So we're going to move this x to the negative 5. We're going to move it down to the denominator. So it turns into x to the positive 5. Because all it is just a change of sign. And that 1 will stay in the bottom. Because it's just a power of an imaginary 1. A to the power of 3, well, that's positive, so you just leave it up there. So our final answer would be a to the third divided by 1x to the fifth. Now the reverse also does the same thing. So let's say we have a negative power in our denominator, in our bottom of our fraction, like we do here. We have b to the fourth divided by c times x to the negative 3. We got to get rid of this x to the negative 3. We got to move it to the numerator to change that negative 3 to a positive 3. So that's what we do. So we have x to the power of 3, because we moved it up top. B to the power of 4, well, that stays the same, because it's already a positive. And c is already a positive, so you leave that positive c there. That's our final answer. Let's look at the problem here. Well, we have a to the third. Well, that's a positive power, so we leave a to the third in the numerator. We have 1 times x to the negative 5. Well, x to the negative 5, since there's a negative there, we have to move it from the bottom to the top. So at x to the negative 5, we move it to the top, and we get ourselves x to the power of 5. So a to the third times, let's put a little times symbol in there, times x to the fifth, divided by, well, 1, it has a power, an imaginary 1 in the power, so we just leave it there. So we have a to the third times x to the fifth divided by 1. And you guys know if you divide anything by 1, you could just take your numerator. So in fact, we don't even need the 1. We don't even need a division bar anymore. And that will be our answer. A to the third times x to the fifth. Alright. Another concept that I need you guys to become more and more familiar with is combining like terms. We're going to recap that a little bit more. So let's say we have a problem like this. Make it a little bit bigger on your screen. We have x to the fourth times x to the fifth times x to the third. When the base or the number there is the same, we could actually add up all the powers when we're multiplying all these bases together. Meaning, since we have an x here, an x here, and an x here, we could combine or add all these powers. So 4 plus 5 plus 3 gets us a total of 12. So we have x to the 12th. So anytime you have the same base, meaning the same letter, or really just the base of the exponent, you just have to add up the powers. Let's make things a little bit more sense when I mean with the vocab words, as I find myself saying base quite a bit. So we have x to the power of 3. And we have the 2 in the front. This is a little bit of a review, just in case if you forgot. We have positive 2 times x to the power of 3. As far as our vocab, the sign in the number in front of the x is called the coefficient. So that's the coefficient. That's in front. The variable is called the base. So in this case, our x is the base. And 3 is called our power. So that's the vocab words. So the coefficient is the sign and number in front of the base. The base is the bottom of your exponent. And then 3 is the power. Alright, let's just make sure we got it. Let's do one more. Then we're going to go into more of the difficult problems that you're going to be seeing. So let's say we got b to the power of 4, b to the power of 8, and b to the power of 6. Well, the answer to that would be b, and then we just add up all the powers. So 4 plus 6 plus 8, that'll get you a total of 18. So it'll be equal to b to the power of 18. Alright, let's do a couple problems together. We're going to combine these two ideas. So we have 4x to the power of negative 4 times y to the power of negative 3 times 2x to the power of 2 times y to the 4th. Well, numbers we could put together. 4 times 2, you guys know, is 8. So we're going to have 8. Then x to the negative 4 times x to the power of 2. Well, negative 4 plus 2 gets us negative 2. So we have x to the power of negative 2. Now our y's. Y to the negative 3 times y to the positive 4. Negative 3 plus 4 gets us positive 1. So y to the positive 1. Now those are all the combined like terms. However, we can't have a negative power in our exponent. We have to get rid of that. Now, just like we talked about before, anytime you have a negative power, if it's in the numerator, you move it to the denominator. And when you move it to the denominator, that negative sign turns into a positive sign. So you have 8y to the first divided by x squared, which is going to be c for number 1. Let's try number 2. We have a to the third times b squared times 3 times b to the fourth times 3 times a to the fourth. Well, 3 times 3 you guys know is 9. So we got 9. Let's do our a's. A to the third and a to the fourth. Well, those two a's can be combined. 3 plus 4 gets you a to the seventh. B squared times b to the fourth. Well, b squared times b to the fourth, that's b to the sixth. So our final answer is 9a to the 7th times b to the 6th. Let's look at number 3. So we have x to the negative 2 times y to the negative 1 times 3 times y times x to the negative 2. So let's do the numbers first, though. There's an imaginary 1 in front. So 1 times 3 will just get us 3. Now x to the negative 2. Oh, this is all times, so we could combine this stuff too. So x to the negative 2 times x to the negative 2. Well, negative 2 plus negative 2 is x to the negative 4. Then we have y to the negative 1 times y to the positive 1. Well, negative 1 plus 1 gets us 0. So y to 0, well, that disappears. Anytime you have any variable to the power of 0 or a number to the power of 0, is just equal to 1. Or it could just disappear. Alright, so that's our final answer. Now, since we have a negative power, we gotta move it from the numerator down to the denominator. So, we move it from the numerator down to the denominator, the base and the exponent. And just the base and the exponent will move. And when you move it, it changes, it gets rid of that negative and it becomes a positive. So you have 3 over x to the fourth. So for number 3, the answer is C. Number 4. We have 4y to the negative 4 times x squared times 3x to the negative fourth times y squared. Now we gotta simplify things out here. We have 4 times 3, which gets us 12. So we took care of the numbers piece. And notice I could do all this because everything is being multiplied together. That's why I could just multiply the two numbers. And then add the exponents. So you have y to the negative 4. Well, y goes with y. So y to the negative 4 times y squared. Well, negative 4 plus 2 gets us negative 2. So we have y to the negative 2. Now x squared times x to the negative fourth. Well, 2 minus 4 gets us x to the negative 2. So you have 12 times y to the negative 2 times x to the negative 2. Now, since we have some negative powers, we gotta move things around a little bit. Since we have a negative exponent, we gotta move it down to the bottom. Let me change that -2 into a +2. This x to -2, that also got to move. So I move that to the bottom. Now it's always good idea to do things in alphabetical order. So you should have your x squared come before your y squared. Oop, can't really see it on your screen, huh? X squared times y squared on the bottom. Alright, let's do another one. Number 5. So 2 times 2 is 4 times 1, which is 4. So we got 4. Then you have x to the third, x to the -1, and x to the fourth. So 3 minus 1 gets you 2. 2 plus 4 gets you 6. So 4x to the 6. Now we do our y's. Y to the fourth times y to the, that's an imaginary 1. So 4 plus 1 plus 4, which gets you a total of 9. So y to the 9th. And since each one of these powers are positive, we don't have to do any movement. So our answer is 4 times x to the 6 times y to the 9th. And that's our final answer for number 5. Looking at number 6. We have 3 times 3 to the power of 4 times 3 to the power of 2. Well, our 3's are now just the bases. So this is where it gets a little confusing here. So instead of having, when we don't have an x or any variables, that coefficient turns into the base now. The reason why it's the base is because there's a power on the number. So the power tells us what the base is. So 3 to the power of 4 times 3 to the power of 2. Since this base is the same, we could add the powers. So 4 plus 2 gets you 6. And this is 3 to the power of 6 because you have the same base. So our answer will be 3 to the power of 6. Since it's a positive power, we don't have to move it to the bottom. So our final answer will be D. It's for 6. Let's look at number 7. We have 4 to the power of 2 times 4 to the power of 4. Well, since the numbers, those have the same bases, the base is 4, 2, we could add the powers. Since they are the same base, you could add the powers. So 2 plus 4 gets you 6. So our final answer is 4 to the power of 6. And that'll be our final answer, 4 to the power of 6, which would be A. Let's look at number 8. This is 4 to the power of 1 times 4 to the power of 0. Well, 1 plus 0 gets you 1. So it would be 4 to the power of 1. Now, anything to the power of 1 is just the base itself. So our base is 4, and that's why our answer is 4 for number 8. I think we got time for one more. So number 9. We have 3 to the power of 1 times 3 to the power of 3. Well, 1 plus 3 gets you 4. So 3 to the power of 4. So our answer is C. Number 10. All 3 of these numbers have a base of 4. So it'll be -3 plus -4 plus 0, which gets you 4 to the -7. And since it has a negative power, we're going to move it from the numerator to the denominator. So it goes from the numerator to the denominator. So meaning it's on the bottom. And you just have a 1 on top. And that's your answer. Like that.